Okay, this is section 7.6. We want to look at, well, let me write it kind of like I did the last one. So two-dimensional center of mass. Alrighty, so in this case, what we want to do is find a balance point for masses that are distributed in a two-dimensional space. And so, here's our two dimensions, and what we do is in essence, we just come up with our moments about the x-axis and the y-axis as if they were kind of zero. So, for instance, I could have a mass here, and maybe that's at what, -2, 2. I could then have a mass here at 2 and 1, and maybe this is a mass of 5. Here's a mass of 3, and maybe down here I have a mass, there's 1 and -1, and maybe this is a mass of 6. And so if I want to find the moment about the y-axis, that would be very similar to what we did in one dimension, in that what we want to do is just determine, so this is first our moment about y. We want to just determine those x values. Right, so our moment about y is, we're really, a nice mathy term is, in essence, we're projecting our masses down onto the x-axis, so like this. So it's like they're at those three spots at -2, 1, and 2, and we just want to know, okay, what's that moment about the origin? But we'll call it the y-axis because that's what we are perpendicular to, is that y-axis. And so, just like in one dimension, well, I will just take my 5 times -2 plus 6 times 1, okay, and plus 3 times 2. Okay, so I'm just taking those distances from the y-axis, which are x values, and getting it that way. So that is what, -10 plus 6 plus 6. So that ends up being 2. And similarly, I can find the moment about the x-axis. Now, for the x-axis, I want to think of these vertical distances, because I want to, if it's about the x-axis, I want to treat that as sort of the 0 and ask how far are each of these away, and so I will get my 5 times a +2 this time, and 3, well, I'll do the 6 first, I guess. 6 times -1 for that distance, and then 3 times 1, so plus 3 times 1. And so you see, I was looking at these distances with signs, okay, because we're treating, the x-axis as 0, and we get 10 minus 6 plus 3, and so this ends up being what, 13 minus 6 is 7. Okay, so our moment about x is 7, And then to get our center of mass, okay, our center of mass is x bar, y bar, okay, and we calculate those just as we did before, but this is the thing you got to be careful of with your notation and so forth is, see this m sub y? Remember that m sub y was using this as 0, this y-axis, and so we were taking those distances, those are the x distances. And so this is m sub y over m, and similarly m sub x over m. So they, by the notation, they look backward. Okay, and that's just something to remember. And we hadn't calculated m, so let me toss in m. We had a mass of 5, a mass of 6, and a mass of 3, so that's 14. And so we get, for our center of mass, m sub y was 2, so we get 2 over 14, and m sub x was 7 over 14. And so this is 1/7 and 1/2. Now going back up here, 1/7 and 1/2. 1/7, you know, is pretty close to 0, and 1/2 is also darn close to 0. You know, we'd be right up in here. Now that looks like it makes sense. Let's try to get something that's a little more obvious. Let's try one more example, and let's make it so that it's pretty obvious that we should get a negative number for one of them and a positive number for the other. And so, you know, we could do something like that by just taking this and saying, well, you know, how will I be sure that I should get a positive x bar, say? Well, most of the mass should be on the right side of the y-axis, right? So, you know, I'll put a mass way out here and make it kind of a big mass here. So this is maybe a 10, and this is at, I say way out here, maybe this is 4. So there's a 10 and 4, and then we could, you know, make that at like a height 2. Now, to kind of make sure, though, we get a negative, you know, let's come down here to -4, and maybe a 2 there. And let's make this even bigger, you know, maybe make that a 20, because then as I look this back and forth this way, up and down, you know, that 20 should definitely outdo the moment there. You know, I've got a moment of 20 looking at that distance. Here I've got a moment of 80, so that should really knock that out. And then just to toss in a little bit more, let's go here to -1 and -1, and just put in a mass there of like 5. Okay, that's probably, you know, as I look at that, right, there's way more mass on the right-hand side, so I really ought to get an x bar that's positive, and then definitely way more mass down here in the negative portion of the y, so I really should get a y bar that's negative, you know, as I look at those moments. So, you know, let's check that out. First, we want an m sub y, okay, and so that's for our x's, and again we're looking at these distances, and so I have a 5 times -1 plus a 20 times 2, and 10 times 4. Okay, so I'm looking at all those horizontal distances when I do m sub y. And so I get 40, and 40 is 80, minus 5 is 75. And then m sub x is making the x-axis the center, and or the origin. I shouldn't say center, the origin. And as we look at that, so I'm looking at these distances, and what I see is again a 5 times -1, but now the 20 is times 4, because well, actually -4, sorry, plus 20 times -4, and then 10 times 2 there. And you see we get -5, -85 when we add that, plus 20, so we get a -65. And for m, we have 5 plus 20 plus 10, and so that's what, 35? So we get m of 35. So then we have x bar is my over m. So that's 75 over 35. What the heck is that? That's 15 over 7. Okay, definitely a positive number. And what is it? A little bit more than 2. It's it's right in here somewhere for that x. And as I look at those, sure, that seems reasonable. That yeah, we might balance out somewhere around that 2. And then our y bar is m sub x over m, and that was a -65 over 35. And so that's a -13 over 7, so a little bit less than -2. Well, a little bit more toward the origin than -2. So if -2 was in here, we're right in there somewhere. So it says our center of mass is maybe about there. And as you look at that, for that point, and that point, yeah, that seems reasonable that you might balance somewhere in there, maybe, sure. But then, so our center of mass is the x bar, y bar, and we have 15 over 7 and -13 over 7. Okay, so the big thing is remembering that the m sub y is the x direction, and the m sub x is the y direction.